Let's talk about multi-factor authentication in the context of a castle. This is a great way to look at some of the basic security credentials and security mechanisms that are possible in the cloud, but also have been around for thousands of years. Let's take a look at this castle here. If you're going to gain access to a secure castle, you have to know more than just one thing, right? You need to know the passphrase, and the guard is also going to check for something that you have, like a royal crest. This is called two factor authentication, and it's a stronger level of security because you're relying not just on a single factor, like a password, because it's risky. A password could be guessed, it could be stolen or cracked, and anyone who learns it could impersonate you. With two factor, an imposter would need two pieces, something you know and something you have. Even if they steal your passphrase, they can't access the castle because they don't have your royal crest. The same principle applies to secure computers and online accounts. You can use a password you know plus a security key you physically possess, or even combine a PIN code with your fingerprint. The two factor authentication has become one of the best practices for security. Banks use it to prevent unauthorized transfers, companies enable it to protect employee accounts, and the extra step takes a little more effort but greatly improves the protection against infiltration. So, really, when you're thinking about setting up a new account, look for an option to turn on two factor authentication. It's a simple way to boost your defenses against an intruder. And also, it's important to note that adding a second layer of authentication is like a moat around the castle. You'll be able to sleep more soundly because you know your accounts and your data are better protected. Let's take a look at a castle for a network segmentation example. A castle would divide its grounds into separate zones. There would be an armory, royal chambers. Those would be heavily guarded because of the importance of those particular parts of the castle. A kitchen doesn't need as much protection, and there are the gates between the control of the flow of people. And in terms of segmentation, it increases security and would reduce risk. So, an intruder getting into the kitchen can't readily access more sensitive zones, so the damage is contained. So, computer networks are very similar because you can divide the network into segments isolated by the firewalls. Public facing web servers go in an outer zone called a DMZ, and inner zones hold the sensitive data like customer records. And segmentation controls access between those zones. So, this would limit an attacker's ability to move laterally and cause wider damage. And the users and devices would only interact with systems they need to. So, in a nutshell, the network segmentation is a powerful security practice, but takes some planning. The group is going to be designed by function, sensitivity, access requirements, and then more trustworthy zones get more access. So, for example, a database server might need a restricted segment, an application server would then need to query that database, but be given specific access just for that, and other systems would be blocked. And so you can think of each zone like a castle courtyard. There's drawbridges that are raised or lowered to enable the flow between the areas, and segmentation would protect critical data and assets. So, in a nutshell, firewalls and VLANs divide networks into secure zones. You can restrict access between zones to reduce the radius of an intrusion. You also have intrusion detection systems that look out for anomalies. You could have subnetting and VLANs for network partitioning, and also you could access control lists for interface permissions. And you could even look at the packets as well in firewall, and then intrusion detection systems and heuristic analysis. So, really, it is a lot like the old school castles from back in the day. And the concepts are similar when you're thinking about protecting your network. Let's take a look at least privilege access as a security context inside of a castle. In the computer world, obviously, we know about you want to limit the amount of privileges you give a user until they ask for them. That's really the same concept in terms of a castle here. So, within a castle, the access is strategically restricted. The count, for example, could enter any area of the castle, but a servant could only go where they are needed for their duties. And the least privileged model enhances this security level. In a similar way, there are users and programs that should only get the necessary permissions in a computer system. If you give excess access, it's going to increase the risk that there could be some kind of an abuse. For example, if a castle guard doesn't need access to the treasury or a kitchen cook doesn't need to enter the barracks, their jobs are limited to those authorized areas. In a similar way, with computing, authorization is controlled through access policies. This means that a database application will get read and write privileges to a certain table, but it shouldn't be able to delete, let's say, files on a server. There are effective security grants that have only the minimum amount of access required. The additional permissions can be added if the responsibilities grow. But there's a strict baseline to start with. Unfortunately, many organizations start with an overly permissive access model. Then what happens is you try to later lock down security and there's problems. This is like letting everybody into the castle before you restrict certain areas. It's better to adopt a least privilege mindset from the very beginning, although it does take a little bit more work up front, but it does greatly reduce the potential for damage from mistakes, bugs, or bad actors. And this limit to permission is going to lock down, in this particular example, a castle, but in your case, a digital castle. Let's take a look at encryption from the view of a castle. So within a castle, there are secure chambers, and encryption would keep the conversation private. Secret coded language is used when a messenger bird would relay important communication outside the walls, and the encryption itself acts like an invisibility cloak. This prevents people from accessing the sensitive information, and intercepted messages appear meaningless to anyone lacking the cipher key. Modern computing would then rely on encryption to protect data both at rest and in transit, and the powerful algorithms would scramble information so only authorized parties can read it. Encryption keys unlock access to data, and with symmetric encryption, the same key would both encrypt and decrypt. This is the way that you would encrypt files stored on a hard drive, but for secure communication, asymmetric encryption is used with a public and a private key. So you'll see this with SSH, you'll share your public key, and then your private key will be able to uh, unscramble that data so you can actually use it. Now, in terms of proper key management, now it becomes critical because the safeguards of encryption are not going to be in place if you lose your key, your private key. And what could happen is that the data becomes unusable, or if someone gets access to your data and they have the private key, they could decrypt the data. So applying encryption across systems and networks will prevent unauthorized access to sensitive materials, and it transforms data into a secret code that appears like gibberish to intruders. So really, a medieval castle here has a lot in common with some of the things that we're doing with modern day encryption. Let's take a look here at a example of immutability and why it's so important as a security design of the Rust language. Here you have a Rust function, and in the very beginning here, we create a vector of fruit. So this is like a Python list. But one key difference here is, notice when you say let, you actually are setting in stone what is going to be inside of this vector. So you can see it's apple, banana, cherry, dates, elderberries. And if I go through and I print this, we'll be able to get our result. Now, if I wanted to try to make a change to this here, what's going to happen is that there's going to be a compilation error because this has been designated as an immutable data structure. This is an advantage because by default, it's safe, right? So if you accidentally did something in your code that pushed something into the list or mutated the list or corrupted it, you may have a problem catching that in a interpreted language, but in a modern compiled language like Rust, all you have to do is have the compiler here really protect you from accidental errors. Now, if we do want to mutate it, what you would do is you would say let mute, and you would declare this as a mutable variable. And you can see here that this fruit salad would be a vector that would contain some strings here. And then if I wanted to afterwards, I could push those figs. So what we can do here is comment this out first. And first, let's just run the code that's very simple. So let's go ahead and say cargo run. And you can see your original fruit salad. Now, if I try to mutate that vector, we're going to get a compilation error. In fact, we can even see from the error checking here that even before I compile, it says you cannot mutate immutable variable, right? So this is an amazing feature that you get in terms of safety from the Rust language. Now, if I go ahead and I, try to do it anyway, it's going to say, nope, you can't borrow as mutable, and it gives me the exact line of code, which is right here, and it says, look, let me tell you what you should probably do. Now, this is one of the advantages of the Rust compiler is it's not using, generative AI or some kind of fancy technique. It knows what the code should look like, and so it can tell you, look, you probably mean to make this mutable. Why don't you go ahead and make that change? And so, again, this is an amazing feature of the Rust language. Now, if I go back to the other example here, what we can do is we can actually then mutate this, and let's run it again, and you'll be able to see it at. In fact, the original fruit salad was this data structure, and the modified fruit salad is here. So I think as you use Rust more and more, you'll start to appreciate the fact that even though you built something once, it could run a million times. And so by spending a little bit of time up front and protecting yourself, you're actually saving time in the future in case, code was modified or there's some kind of change, is that you can rest assured that certain errors just don't exist in the Rust language.